Okay, this lesson is again for section 2.2, other types of equations, part 2. So today we're just going to review again literal equations, absolute value and radical equations, and equations using nth roots. And then at the end you're going to also solve some equations that are quadratic type equations. Okay, so the first example for this literal equation, remember literal equations just mean that they've replaced everything with variables, and I know you guys have said that these are a little difficult for you, but just remember you can only follow the same rules that you follow whenever there's just numbers, so don't make up any kind of new math basically. So when you see a variable in the denominator that you're trying to solve for, like in problem number 1, you need to make sure you get it out of the denominator. So I'm going to multiply on both sides here by z plus w. So when I do that, I end up with z plus w times w. I'm going to put the w out in front, equaling just z, because of course these are going to cancel. Alright, now, if I try to get the z over here, because it's my next step is to try to get all of my variables to one side, if I try to just move that, I can't break this apart because it's inside that parentheses, so that would be a rule that you'd be breaking if you just try to subtract z by now. So instead you're going to distribute so that you can break up that parentheses, and now you can move that term over to the other side. So we can move the z term so that we have w squared equaling z minus wz. And at this point, really crucial, important step here is to factor out the GCF here, the z, to get that by itself. So if we factor out z, now we have 1 minus w equaling w squared here, z times 1 minus w equaling w squared. And now to get z by itself, because we've broken it down and have it alone, we can isolate this just by dividing 1 minus w. So I divide by 1 equaling w squared over 1 minus w. Remember, you can't have z appear on the right-hand side here. If you're solving for z, z cannot appear on the right side of the equation at all. Okay, so that's problem number 1. In problem number 2, we have mostly variables here. We do have a couple constants right in there, not constants, but number terms. So let's move this over. And we're supposed to solve for y, right? Well, if you take a look at what I just did here, by moving over that term, and let's switch the order here, x squared y squared minus 5y minus 3x equaling 0, get out of your head that x is a variable, okay? If you were to treat x like a number, like let's say x was equal to 2, and this would be just 4y squared minus 5y minus 3 times 2 is 6, right? And this would be something that you would use quadratic formula for, you'd try to factor it, it's just a quadratic. So you want to be able to recognize that in this case, this is also just a quadratic. If you're trying to solve for y, this is simply a quadratic. This 3x can be treated as a constant term, okay? So let's go ahead and we'll solve for y. The easiest way to do this, since I'm not going to even try to factor this, is just to put it right into the quadratic formula. So I'm going to do that and let a equal x squared, b equal negative 5, and c equal negative 3x. Okay, so you guys can go ahead and put that into the quadratic formula. I'm going to do that real quick and pause the button so that you can see my work. Okay, so here I have the quadratic formula just using a, b, and c that I defined up here. I'm just going to simplify this now. So y is going to equal 5 plus or minus the square root of 25 plus 12x cubed over 2x squared. So this is solving for y in terms of the other numbers and variables. So don't make it too complicated on yourselves, just make sure that you can recognize when something is a quadratic equation. Even if it's not factorable, you can still solve using quadratic formula. It's just they become tricky when you see more variables in there. So don't get confused, just try to see and recognize quadratics. Okay, so my suggestion for the rest of these would be to try to do the rest of these. These are all just review questions, but try to do them on your own. Then come back if you check the key first. If you get them right, you can stop the video here. If you don't get something right, though, you can skip ahead to the parts where you missed it and then listen to the explanations. Okay, so sorry, this is actually supposed to be t for the first 2 examples here and then x for the other ones, but we're going to solve for t here. And I noticed right away that t is factorable, or t minus t cubed, this expression is factorable. So I'm going to pull out GCF of t. So t times 1 minus t squared equaling 0. And then I can further factor this, because this is the difference of squares. This is t times 1 plus t and 1 minus t equaling 0. And I get three distinct solutions here: t equals 0, negative 1, and positive 1. Okay, now in the second example here, number 4 of the review, this is a radical equation. Remember, you always want to isolate your radical. So I'm going to move, I'm going to move this one over to the right-hand side so that I can get this guy alone. So I have negative 1 plus 4t over the radical equaling 1 minus root 3 plus 2t. I am now going to square both sides of my equation here. This radical is going to drop, leaving me with just negative 1 plus 4t equaling, on the right hand side, this is another opportunity for you to practice that. You know, when you square something, you have a perfect square, you just need to take the first term and square that. The middle term is going to be found by multiplying these two terms here and then doubling it. So I would have negative 2 times 3, or the root of 3 plus 2t. And then the last term is just going to be your second term here, which is, this term, negative root 3 plus 2t. Square that, so you get positive 3 plus 2t. Alright, now I still have a radical on the right hand side, so now I work to get that one isolated. So it's just kind of keep going until you don't see any more radicals. So now we're going to subtract these terms over the other side. Let's see, that's going to be negative 3, or sorry, negative 5. Right? Yeah, negative 5 plus 2t equaling negative 2 times the root 3 plus 2t. Okay, so in this example, here's a case where I would not want to try to just divide by negative 2 here, because this is not divisible by negative 2, so it's going to be too hard. I'm going to get a fraction. Don't even worry about that here. So I'm just going to square both sides. My dogs are playing tug of war. Hold on. Okay, squaring both sides, I'm left with 25 minus 20t plus 4t squared, equaling, this is going to be a positive 4 now, times 3 plus 2t. So remember to square this first term and the radical, okay? Alright, now this is just going to become a normal quadratic, so you see this t squared term here. So I'm just going to move everything to the left and solve this quadratic. Okay, so I'm going to distribute the right hand side here. And I'm going to now move these terms over to the left. So I have 4t squared minus 28t plus 13. And if I can factor this, I'm going to go ahead and try to factor this. Let's see, negative 52, 14. I don't think it's factorable, so I'm just going to try to put this right into the quadratic formula. So just go ahead and put that in the quadratic formula and then check your solutions with the key, because I think you've seen the quadratic formula plenty of times. You know what to do at this point. Alright, let's go to problem 5 here. So in problem 5, I don't need to, expand this at all. Don't waste your time doing that. Just isolate this expression here. So I would move over that 16. And now I'm going to take the fourth root of both sides. So I have x minus 2 equaling the fourth root of 3. Now when I do this, the fourth root of 3, remember, since it's an even exponent here, I'm going to get two unique solutions, positive or negative, fourth root of 3. So I get x equaling 2 plus or minus the fourth root of 3 to get me two unique solutions here. In problem number 6, this is not a typo. The reason why is because I want you to see when you subtract that 19 over the other side and you try to take the fourth root here, this is not real. So this has no real solutions, and we stop. Okay? Alright, now on the back side there's a mixture of some problems here. This is kind of like what your test is going to be like. You're going to see a whole bunch of different types of problems, and whether they're not going to be labeled with like solve this quadratic type, solve this linear equation. So I just wanted to give you some more practice with seeing multiple problems. Okay, sorry, this one's a typo here, number 10. Let's change this right hand side to actually the whole thing. Let's just keep it, the absolute value of x minus 3 is less than or equal to 0. Okay, so I'd like you to solve these again and try to check with the key. come back and listen to the explanation if you did not understand part of the problem. Okay, number 7 here, I can cross multiply here to get rid of x in the denominator, or I can multiply by x plus 5 times x plus 3, you know, and remove that from the denominator as well, just so you have a linear equation. So it's however you really want to think about it. I'm going to cross multiply, and I get this, and I do have a quadratic here on this side, so 7x plus 35 equals x squared plus x minus 6. Subtract over your 7x. And then subtract over 35. And solve this quadratic using the quadratic formula because this is not factorable. So I'm just going to leave it as quadratic formula here. And again, you guys can check the key. Okay, in problem number 8, this is an equation that is of quadratic type because if you notice here, you've got one exponent double the other and you have a constant term. So let's let t equal x to the 3/5. So that way I can solve a new quadratic equation, 2t squared minus 3t minus 5. So this is factorable. 2t squared minus 5t plus 2t minus 5 should equal 0. And I'm going to factor out a t here, so 2t minus 5 plus 1 times 2t minus 5 should equal 0. So I now have these two linear terms here for this particular quadratic. And I solve and I get t equals -1 and t equals 5/2. Okay, now I'm going to substitute back in x to the 3/2 here. So I have x to the 3/2 equals -1, right? I'm just substituting t back in x to 3/2 and back in for t. So x to the 3/2 now equals 5/2. Okay, now to solve this equation here, I want to raise this to a reciprocal power of 5/3. So I'm going to raise each one of these to a reciprocal power of 5/3, raise both sides. Okay, and here I get x equaling -1. When you raise -1 to the 5/3 power, you still get -1. And over here I get a number that, this is the exact, you can plug that into your calculator to get an approximation. So I do have that on the answer key so that you can check to see what your approximate value should be if you want to see what it is in your calculator. Okay, question for you, because here we have the absolute value equaling another absolute value. So really there's only two cases here. Either these two things are already equivalent to each other, so x minus 3 is equal to 3x plus 6, or they are opposites of one another. So x minus 3 would equal the opposite of 3x plus 6. So they're either equivalent or they're opposites, and in which case you're just going to solve these two basic linear equations. So solving for x, I get 2x equaling -9, so x equals -9/2. Over here, once I distribute, and I get -4x over 3, so x equals -3/4. Okay, so really the only thing here, because it's a good thinking question, is to understand the concept here. Either, since it's absolute value, right, like let's pretend like it's, you know, something like this. So either the insides are already equal, like in this case, the absolute value of 4 is equal to 4, so you would have an equation 4 equals 4. Or they're opposites, in which case, you know, 4 would equal -4. But in order for this to be true, absolute value equaling absolute value, these are the only two cases, and you need to set up both cases and solve both cases separately. Okay, let's move over to question 10. So I changed this one. There's a typo beforehand. But the absolute value of x minus 3 is less than or equal to 0. So this is, again, a thinking question here. When is it true that this is going to be less than or equal to 0? Well, because you have absolute value here, if this was strictly less than 0, this would be impossible. There is no solution here. But because this is equal to 0, we're just going to set x minus 3 equal to 0, and we get one solution, x equals 3. So this wasn't a really difficult question, but it is a thinking question again. So make sure you're paying attention to your signs and thinking about where it's possible and it's not possible. Okay, that's the end of the review for part 2.